level we know oxygen helps in combustion, but the water actually doesn't help it. It extinguishes fire. So once you have the chemical bond, you get a species which is a new molecule, which is different, which may have different properties from the combining atoms. And what is the actual reason for the chemical bond formation? What is the reason for the chemical bond formation? What do you think is the actual reason for chemical bond formation? Why do atoms combine together?
To sell their
Stabilize.
orbitals.
Yeah. So the old theory was, as per the Lewis approach, or Lewis octet rule. The atoms uh, participate in chemical bonding to attain 8 electrons in their valence shell. If the valence shell is incomplete, they will try to form the chemical bond, okay, and they will try to have their valence shell complete, means 8 electrons, or 2 electrons in the case of hydrogen. Is it clear?
Yes.
That is called Lewis octet rule. Atoms combine with each other to form molecules. Okay, they combine with each other to form molecules. So that their octets get completed. Okay. So what do is that? And there are two ways to do that. Okay. And the two ways are actually, one is through transfer of electrons, complete transference of electrons. That will lead to the formation of a cation and anion, which are held together by electrostatic force of attraction, or through sharing. Is it clear? So it can be attained by two different ways. One is through sharing. Another is by complete transference of electrons. Through sharing, it is going to form a covalent bond. And this is going to form the ionic or electrovalent bond. Covalent bond is going to form between Generally, metal and non-metal can also form covalent bond, but generally between two non-metals, they most commonly form the covalent bond. And ionic bonds are formed between metals and non-metals. Okay. But the question is, before we proceed to the Lewis octet rule, now we have a lot of molecules. Is it the ultimate criteria for the bond formation to complete the octet or duplet? Is it the actual reason for the bond formation, or the actual reason may be something else?
I mean, we have studied that they share electrons, gain electrons, or whatever to complete their outermost layers till now.
Hmm. But is it the actual thing which is causing the atoms to combine to complete the octet, or is there some other thing which may be behind the curtain, and that is responsible for making the atoms combine with each other?
Maybe positivity and negativity.
Yeah, something like that. Actually, it is the universal statement which you are going to say is attainment of stability. Is it clear?
Yes, sir.
So why do atoms participate in bond formation? Which is always true? Which statement is always true? To have their octet completed, is this always applicable? Or attainment of stability is always applicable?
Stability. Both.
Attainment of stability is always true. Why do atoms participate in bond formation? Suppose if I give you a reason assertion question in which I give you the first statement. All atoms participate in bond formation. Okay. So statement one, both are true, both are false. And if both are true, is the second explanation of the first, or is it not the explanation? Both are true, but the second is not the explanation of the first. Can you see the statement 1 and statement 2 clearly? Very, very important thing. Okay.
Yes.
So just tell me which is going to be the right answer. Just take them one by one. Statement first.
Statement 2 is
First, we can discuss the first one. Yeah. So first one, Maha and Navila, is it correct?
yeah.
Statement. All atoms participate in bond formation. Do all atoms form compounds? Or there are certain atoms which cannot form compounds?
Yeah, they cannot all form compounds.
Hmm. Like helium,
No,
right?
no.
Ma, is it clear? Neon, they are noble gases and they generally do not have tendency to form chemical compounds. Is it clear or not?
Yeah.
So all atoms participate in bond formation or chemical bond formation. Answer is no. Many atoms, but not all. Got it? So the statement 1 is false. Right? Second statement. Atoms participate in bond formation to complete their 8 electrons in their outermost shell, to complete their octet in their of their outermost shell, or 8 electron in the outermost shell. Is that true?
Yes.
Yes.
Many cases it is true, but not always. This is also false. There are many molecules where they are formed, and while forming their octet is not completed. Okay. This is generally true. Generally, there are many examples. But if something has not many examples, that doesn't mean that it is always true. There can be molecules which do not follow this. Okay. And there are many molecules. Okay. Where they either after the bond formation, they do not have 8 electrons in them. Either they have less than 8 or more than 8. Okay. And what are those molecules? These are hypo and hypervalent. Got it? For example, hypovalent is BH3, AlCl3. Are you getting my point? How many electrons
Yes.
are there? 6. Not 4 bonds, just 3 bonds, 6 electrons. So hypo means less than 8 electrons. Are you getting my point or not?
Yes, sir.
And
Yes, sir.
hyper means more than 8. There are many cases, and actually, for example, SO3. How many bonds this SO3 is having?
Right.
Yeah, 6 bonds, and each bond carries 2 electrons, right? So 12 electrons. Got it? So 12 electrons. So it is not PCl5. How many bonds? 5. Each bond. I'm drawing the structure as of now.
10.
Yeah, 10 electrons. So now one thing is sure. Is the octet completion is the sole criteria for the bond formation? Yes or no?
No,
Yeah.
sir.
Not the sole criteria, not there.
Okay.
Because we can find many compounds where the octet is not completed. Got it? Even after the bond formation. Or there are many compounds where the octet is expanded. Okay. So one thing is sure that the octet completion is not the sole criteria for the chemical bond formation. Is this clear to everyone?
Yes, sir.
Yes.
Okay. And so there may, but it is, there are many molecules. So we start thinking that, so all the atoms, why do they form bond? What you will say? They will form the bond because they want to complete the octet. Got it? Say it like this. No, but that is not the case. There are certain atoms where the octets are not completed, or they may go beyond 8 electrons. Is it clear?
Yes, sir.
Okay. So so now the question arises, what is the actual thing which we should say, which is the reason, as a reason for the chemical bond formation? Why the atoms participate in chemical bond formation? What is the actual reason? What reason should we say? Actual
Stability.
reason. Just a sec. Actual reason is, yeah, actual reason is,
Stability.
yeah, to attain stability, right? Attainment of stability. Is this clear to everyone?
Yeah.
Yes.
So just give me one very simple answer to a very simple question. Okay. But whatever the answer you should give it to me should be always true. My question is, why do atoms participate in bond formation? To
To attain stability.
gain stability. Yes. Okay, this is always true. To complete their octet, it may not be true always. Okay. Right? I have shown you, I have given you examples. These two terms you should keep in mind, hypo and hypervalent, because you will have questions in your examination where they're going to ask you how many molecules among the given molecules are hypervalent or hypovalent. Hyper means more, right? Something which is higher. Hyper.
Yes,
Yeah,
sir.
hypo is lower. Got it. Lower means less than 8. Hyper means more, higher. Is it clear?
Yeah.
So
Yes, sir.
now,
Clear.
yeah. So, but it started from Lewis approach. Lewis actually thought of only octet rule in the mind, and he started with the octet rule. So why atoms participate? So as per the Lewis octet rule, this is Lewis approach or Lewis octet rule. That's why the name octet rule also. So as per the Lewis, why do atoms participate in bond formation? The answer is, as per Lewis, they participate in bond formation to complete their octet. Is it clear? To
Yeah.
complete their
Yes, sir.
octet, to have their octet, 8 electrons in the outermost shell. Uh, Atoms will participate in bond formation. Okay. So, and there are two ways to attain octet. One is to completely lose or gain electrons. That will lead to the formation of cation and an ionic bond. Other way is through sharing, mutual sharing, right? So what Lewis did, Lewis, in order to show the Lewis octet rule, but questions will be asked on the Lewis octet rule, though it is not always applicable, but applicable in many molecules, but not always applicable. Okay, be careful in whatever I'm saying. Okay, So Lewis octet rule, Lewis said that the atoms must be represented, the valence electrons of the atom must be represented as dots. Is it clear?
Yeah.
Yes.
And dots, like suppose if you want to show the boron, the atomic number is 5. So 2 and 3. Only the valence electron participate in bond formation. The inner shell has 2 electrons. It is complete. So that I will not show. I will put only 3 dots on the boron. Got it? How many dots I'm going to put on the next element? Carbon. 4. Okay. Oxygen. Oxygen, the atomic number is nitrogen. Not oxygen first. First we will put the nitrogen. 7. So 5 electrons. 1, 2, 3, 4, and 5. I am representing only the outermost electron. Oxygen, 6 valence electrons. Fluorine, atomic number is 9, 7 valence electrons. And neon is having complete octet. Okay. So atoms have this combined with each other to so that they can help each other to complete their octet. Okay. And how do we show them? We represent the outermost valence electron with the help of the dots. Okay.
Okay.
And these dots will try to pair up with the dots of the electrons, means valence electrons of the other elements which are going to combine with them. Once they come together, once they are, and they are written side by side, the electrons of one atom are written side by side with the electrons of the other atom. And once they are written, it is said that the sharing has occurred and the covalent bond formation has occurred between them. Once they have the bond formation, the electrons, shared a pair of electrons, become common to both the atoms. Okay, so now by doing this, by sharing these valence electrons, the atoms can have a chance to complete their octet. They can increase their number of electrons by sharing, because by sharing whatever the electrons which are shared by other atom, they are considered to be the electron of the atom itself, the original atom itself. Okay, thus it will help the atoms to complete their octet. Okay. And normally, in order to avoid confusion, atoms of electrons of one atom are represented by dot, and for the clarity, you can represent the atom electrons of other atom by cross or vice versa. Okay. So let's draw some common molecule, Lewis dot structure of the common molecules. BH3, CH4, this you know already, NH3, N2, O2. Got it?
Yeah.
Let's write the Lewis dot structure. Okay. BH3 I can eliminate because this is not following the octet rule. We have shown the structure of BH3 in the hypovalent species. So you can start with methane, and you might have done it in your class 10th also.
Yeah.
So carbon is having 4 valence electrons, and it will share its 4 valence electron with it need to share all its 4 valence electron.
4 hydrogens.
Yeah, 4 hydrogen, but hydrogen doesn't need to complete its octet because it is the first phase element. It need to complete a duplet. Okay, because the hydrogen want to become like helium. Okay, it is only having one shell. So by coming together, by overlapping, or by bringing them together, a chemical bond formation has taken place, and by doing so, the carbon has attained 8 electrons. Thus completed the octet. That you know already. Got it? Clear?
Yes, sir.
Hydrogen has attained a duplet. But this is how you represent it in class 10, but now you are not going to represent it in this way. This single pair of electron, one pair after sharing, is represented by a line, and that's how you represent a bond. Got it? Is it clear?
Yes,
Yeah.
sir.
Similarly, let's try to figure out the Lewis dot structure of ammonia, NH3. NH3 molecule. Ammonia and nitrogen is having 5 valence electron. And if I share 3 of the valence electron, okay, that 3 will become 6. Okay, because they are shared with the 3 other of 3 electrons of the other molecule. So they will become double. Okay, so 6 and so 5 were there. Out of those, I shared 3. Okay, 3 I shared with the other. They became 6 and 2, 8. That's how it will complete its octet. So let's see it in the form of a Lewis dot structure. So nitrogen was having 5 valence electron, and these 5 electrons, out of these I need to share 3 of them. Got it? So that 3 electrons became 6 and 2 were unshared, right? What this unshared pair of electron is known as lone pair. Got it?
Okay, sir.
And how it is written? It is written like this. And you can see that nitrogen has attained its octet. Total electrons after sharing, they have become 6. Okay, but it has not shared all its electrons because it was already having 5 electrons. So just 3 electrons short of the octet. So it shared 3 of its electrons to complete its octet. What about N2? Just can you help me out, both of you, Nabila and Maha, to draw the Lewis structure of nitrogen or dinitrogen molecule?
Yes, sir.
How should I do it?
We can write them.
Each nitrogen atom will have 6 because they will share one with each other. The
One
last.
electron, one electron, like this.
Yeah.
Yeah.
Will it complete its octet? How many electrons each nitrogen will have?
6.
6. So is the octet completed?
No.
No. Can we do something more to help both the nitrogen atoms to complete their octet?
No.
We
Can
can take more 2 over there and put it in the cross
yeah,
over there.
we can let the other 2 electrons also participate in sharing. Got it?
Oh,
Yeah.
yes.
So let's see what has happened and whether it solves our problem or not. Okay, let's try to figure out. This is nitrogen. Let the 2 electron get shared with the 2 electrons of other nitrogen.
There's 7.
Okay. Now we are having 4 and 7 electrons on each nitrogen. Still,
One more
we are,
electron you can put it over there.
yeah, exactly. So we will so this is also not correct. This was also not correct. This is correct. We will let all the 3 electrons participate in sharing, okay, with the other 3 electrons of other nitrogen. 3 will become 6 and 2 are unshared, so 6 and 2 8, and this is 6 and 2. Got it? Is it clear?
Yeah.
So this is how the nitrogen is going to form, but I am going to write it like this now. N2, it is a triple bond. Okay, three pair of electron. One pair is shared, that is single bond. Okay, between 2 atoms. Okay. Oxygen we can try. So always in any question, first you are going to start with the Lewis structure. Okay, we are going to see many other theories, many other types of bonding. Okay, but the basic and the first and the foremost thing is to draw the Lewis structure in your rough copy, because that is going to give you the idea of the overall picture of the molecule, right? Got it?
Yeah.
Yes, sir.
So to oxygen, let's start. Oxygen atomic number is 8. 2 belong to the K shell and 6 electron to the outer shell. Okay. So I need 2 more. So if I need 2 more, I need 2 of its electron to get shared with the other 2 electrons of other atom. Got it?
Yeah.
Yes, sir.
If I need 2 more, so I need to share 2 electrons. In nitrogen, I needed 3 more electrons. So I shared 3 electrons. So this is now very easy. You can do, both of you can do it very quickly, and you can figure out that this is how the oxygen molecule is going to form, right?
Double bond.
Double bond will be. Okay. And there will be 2 lone pairs on each oxygen. That is also very important. Let's try to figure out F2 molecule. Fluorine. As you know, the fluorine is, the atomic number is 9, so 2 and 7. Fluorine has 7 valence electron. So how many more it will need to complete its octet?
One more.
1 more. So if it need 1 more, it need to share one of
One with
its.
each other.
Yeah. So another F2 molecule is going to come in. And that's how the octet of both the fluorine atom is going to get completed. Is that clear to everyone?
Yes, sir.
Okay. So F2 molecule. But not always you are going to end up with simple molecules. You will have some more molecules with more number of atoms. Okay. There you need to concentrate more, like ethane. So till now we were dealing with only two atoms. Okay, so I will try to figure out how it is going to form CH3. Let's divide it into two parts. Is it clear?
Yes, sir.
CH3 and CH3. To get the idea, okay, and carbon is having 4 valence electron. Its valency is 4. Why 4? Because it is having 4, so it need to share all 4 of its electron to make them double, to make them 8. But the valency of fluorine was only 1. Because it was already having 7 electron, it need to share only 1 of its electron to make it double. Okay, so carbon and carbon. Got it?
Yes, sir.
Now I need to put 3 hydrogen on each one of them. Carbon need to share 4. So one electron it shared with other carbon, and 3 of the electrons it shared with the 3 hydrogen atoms. Same thing the other carbon also did. Got it? And that's how you have ethane molecule in place, right? Clear or
Yeah.
not?
Yes, sir.
What about ethene and ethine? What about ethene and ethine? So to get the idea, you divide it into two. Okay, C2H4. That is CH2CH2. Got it?
Yes, sir.
Right. And this is CH. Right? Carbon need to complete it octet.
Yes.
Normally, in the second period element, we have seen it in the last class. The octet needs to be completed. Got it? The octet rule is valid for the second period elements. Right? So just try to figure out how we are going to do that. Carbon need to share 4 of its valence electrons because it has 4. So it need to share all 4 of its valence electron to make them 8. Is that clear or not?
Yeah.
Yes, sir.
So how we are going to do that? But we have for each carbon we have just 2 hydrogens, and hydrogen can share only one.
Double bond, right? This
Yes. So hydrogen can share only one electron, right? Exactly. Carbon, yes.
carbon will share 2 electrons with the other carbon and
With
carbon.
other carbon, but with hydrogen, yes, because only 2 hydrogen were there, so two for each carbon, 2 electrons were shared. The other 2 electron need to be shared with other carbon atom. Got it?
Yeah.
Okay. Similarly, in this case, you will have a triple bond, right? So you are going to write it like this. But not always you have octet completed, as I told you. There are some atoms, even after the bond formation, they cannot have their octet completed. Like if you want to draw BF3. So boron is the 5th atom, 3 valence electrons. Got it. Two in the inner shell. It need to complete its octet. It need to have 8 electrons. But it is having only 3 electrons. Okay. So let's if the problem is not solved completely, let's try to solve it partially. Okay, that's what boron thought, right? You can think in this way. So boron cannot have 8 electrons. Okay, boron started with 3 and shared all the 3 electrons, right? With fluorine. Fluorine, how many electrons need to be shared by each fluorine atom?
1. Yes, sir.
7. Got it?
Yes, sir.
Okay, even after the sharing, you can notice that why it is a hypovalent species, because its octet is still incomplete. Okay, so that's why I told you what is the real reason for bond formation. The real reason is the attainment of stability, not the completion of octet. Got it? So these are exceptions to Lewis octet rule. Okay, because he was not aware of this thing, stability and all. But now we know that atoms combine with each other to attain stability. Okay, let's try to draw the Lewis structure of another molecule which is not following the octet rule, and that is SF6. Are you getting my point?
Yeah.
SF6.
This is silicon.
Sulfur.
Sorry, sir.
Silicon is having the from belong to the carbon family. It is having the same valence electron which carbon is having. Sulfur atomic number is 16. So what is the electronic configuration? 2,
286.
8, 6. These are the valence electron. So how many dots do I need to put on the sulfur? 6. Got it?
Yeah.
Now fluorine is having 7 electrons valence. Atomic number is 9, so 7 valence electron. Fluorine need to uh, share one of its electron to make them 8. Okay. And there are 6 fluorine, each one of them will share 1 electron each, and sulfur will also share that electron. And you can see that we can't stop even if the octet is completed, because the molecule and this molecule is very stable. Got it? Nabila, am I audible?
Yeah. Yes.
So total how many electrons the sulfur is having after the bond formation? Total,
22 electrons I'm talking.
no, total sulfur is having how many electrons? 12. Got it?
Yeah.
So that octet rule is violated in this. Okay. Is it clear?
Yeah.
Brilliant. So this is the basic idea of chemical bond formation. Okay. The basic idea is to attain stability, but the most commonly we observe that while attainment of stability, you observe that the octet also get completed in many examples, but in not in all the cases. There are lot of other molecules where the octet is not completed. Okay, this is through sharing. But what will happen if you try to form a bond between sodium and fluorine? Sodium, the atomic number is 11, 2, 8, 1. Got it? And fluorine, the atomic number is 9, so 2 and 7. Both need to share one of their electrons. Okay, but the octet of F is completed, but the sodium is not completed. Its octet. It will have just 2 electrons. Are you getting my point or not?
Yeah.
Okay. So what? And one is metal, which is on the left hand side. One is on the extreme right hand side. So how they are going to form the bonds? Is it through sharing? Is it going to happen in this way?
Sodium will only have like 2 electrons.
No, I am asking, is it going to happen in this way? Is this correct
No.
or incorrect? It's incorrect. Got it? It's not going to happen in this way. Got it? Because one is metal, another is non-metal. One is highly electropositive, having very low ionization energy. So it can lose electrons. If it is not able to complete octet by sharing that one electron, and if it can lose it completely, it will lose it. Okay. After losing, it will form Na plus. It will have that 8 electron. Got it? And where that electron will go? That electron will be taken up by the fluorine. It will become F minus
Sorry.
2 and 8. So if there are metals and non-metals and which there is a huge difference between their electronegativity, metal completely lose their electrons. And metals actually it is very easy for them to lose 1 or 2 electrons. That very low energy is required or 3 electrons. So they lose them. But for carbon, this cannot happen. Carbon cannot lose 4 electrons. A lot of energy will be required. Okay, so metal will form cation, so now it will have that inner shell which was already completed. Okay, fluorine get that electron, that also will complete itself. Now the cation and anion they form a bond, but this is a different kind of bond. It is not formed through sharing, but it is formed by electrostatic force of it. Got it? This is
Yeah.
ionic bond, right? Electrovalent bond, right? So let's discuss about it in the next class, right? Let me in the class, okay? And we are
Thank you.
going to discuss more details. By the time you can go through the NCERT, right? Okay, bye bye.